I come from web security background, so I made the web security course at University of Melbourne. So I come from security research, pen testing, red teaming, et cetera, et cetera. And I used to be a software engineer, kind of like Aaron too. And I do a lot of bounty hunting and CV hunting. So why does all that matter? I run a team called the SHIELD team. You can basically think of the SHIELD team as a team of engineers. They're trained software engineers that we turn into security engineers typically. Why we actually go about doing this, it's cost effective, and the gist of it is that it fosters innovation. It basically pushes people to go and say, cool, you can do X, Y, and Z with your time, maybe look at 100 SOC alerts or whatever, but you can also get a bot to go and do that for you, which is typically more efficient, or it depends on how things go. My team deals with everything technical security. So pretty much from anyone clicking on a link in a phishing email or something like that, and trying to teach people not to do that, all the way down to finding an ODA and an EDR. So it's a lot of capacity, and trying to do that between 9 people is really, really difficult. So we turned our speciality into automations. Now, what's quite fun is we actually turned this entire thing into the SHIELD team purely because of the fact that a SHIELD is typically defensive, so you can use it to block attacks, but then again, you can also whack someone over the head with it and it hurts. So it's quite effective offensively too, and that's kind of the entire concept of how we believe purple teaming is. So the story behind this entire team is actually kind of weird. Funnily enough, I was the first security hire in BugCrowd post their mass exodus. And I basically started off, and I was supposed to be there as a pen tester for their applications. And turns out I got heavily catfished. I came in and I was actually supposed to be doing a purple teaming role now. But oh well, you start off and try to figure it out. I was in the infrastructure team, so cloud infra. And if you know me, at least from the 2019 phase, my cloud infra is not very good. So it was a lot of learning, a lot of figuring things out. But then BugCrowd ended up hiring a CISO. He came to Melbourne, we sat down for a bunch of beers and got talking. And then he realized that there was a really weird part of me which not many people actually cared about, which was the fact that I had been an engineer. So he turned around and said, I'll fund you, let's get you 2 engineers and go show me some magic. And that's basically what we ended up doing. So the gist of it was that tools cost a lot of money. And expertise costs money. However, human time is a lot easier to justify, or a lot actually more lenient than trying to go and purchase a vendor for $100,000. So what we ended up deciding was putting all of our money, or a lot of our money, into human hours. Now, I'm not saying we're going to sit down and rebuild something like CrowdStrike, because they do it a hell of a lot better than we ever will. However, there are things that we can do to make CrowdStrike more efficient, and things like that. So we basically provide our humans, our engineers, to go do something more interesting and try to build things in a very quick, agile, fast-paced way. So we decided Lambdas are cheap, and that should be our basis. And now, funnily enough, years after doing this, we decide AI is cheap, and it's also a great way of doing things. So we're going to touch on that. The real quick thing, the way we actually like to do things, just to lay it out in case anyone ever wants to, we Terraform literally everything, so it's all infrastructure as code. You can pick one up, spin it up within seconds, and you're good to go. Everything is a CI/CD pipeline, so we use GitHub, so GitHub Actions. It's all literally an action. You pretty much merge it in a master, and off it goes. Quality checks are done as gates, so hypothetically you don't meet a gate, it kills everything and you die. And all Lambdas are created with specs or specifications stating that X, Y, and Z must be achieved, and you must actually properly fill out all the different areas to be able to state what a Lambda is supposed to do. So the real process flow is that you would start out with the IAM permissions. Now, one big thing, you are a security team, so make sure you do follow the principle of least privilege. Preach, do as you preach. Allow list your resources appropriately, then move into building ECR images based off golden images. So it's literally just pumping whatever requirements you need on top of that. We find typically scheduling Lambdas very effective because a Lambda can run for a second or two and it's really cheap, and scheduling them for every minute is nice and easy. And then spin up your Lambda and associate the image digest, everyone wins. Now, what exactly does my team do with these types of things? So we actually built our own custom anomaly detection because we hated vendors anomaly detection. We've gone through and built logging sources because turns out some vendors charge you about $30,000 just to get seam logs, and that's expensive. You can do that for like $2 with a Lambda. So we did that instead. Alerting on specific types of tools, perfectly fine, but we can do a little bit better. We automate on specific types of behavior, so things like snitching on people when they're doing something weird. Perfect example is when someone goes and posts something they shouldn't on Slack or something like that, we have bots that go through and find them, alert the team, and then the team goes and says, hey, wake up, don't do this. And then the other part is syncing between tools. Some tools just don't sync properly. Now, I know there's a lot of no-code solutions that can go and do this, 100%. However, when you run as lean as we do, we don't necessarily want to use them in all capacities. So my team runs about 80 different Lambdas currently, but the crazy thing is we don't actually have to maintain much of it because Dependabot and things like that just kick in and help us out. Does anyone want to guess how much this actually costs us to run? Any guesses? $200? How much is that?
Less than one engineer.
Less than one engineer. Definitely. So $200 a month is the lowest we have so far. Anyone else? Any guesses? $10. Ooh, aggressive. It's less. Our Lambda bill is currently, so in August 2025 was $1.35 USD, sorry. But September it was $1.40. So we went up a little bit, and that's because we deployed a new Lambda. But yeah, that's literally, I'm not exaggerating, you can check our bill, that's actually how much it is. Now, this does not include things like RDS, obviously, those are much more expensive. However, I'm talking about just the Lambda. So the good, the bad, the ugly. The good is it's cheap and efficient, it's crazy, crazy fast. It's interesting for engineers, so they don't get bored. We have crazy good retention rates in our team because we allow people to go and innovate, come up with new ideas, and we actually have these 6-week kind of sprint cycles for a specific type of task, which we call the innovation tasks, where they basically turn around, we give a single engineer 6 weeks. First 2 weeks is determine the task they want to do. They turn around and find the thing they hate the most in their job, and then come and tell me. Next 2 weeks is turn around and build a plan. So build a plan for how to automate it, and the final 2 weeks is actually building it out and testing it. So it's quite literally just that. How do you make your job less shit? It's allow people to do it. And it's fast-paced. It doesn't require a huge amount of approvals or anything, so we can spin up a Lambda in less than a day kind of thing. All you need is approval from a peer, and you're good to go. So nice and easy. Now, the uglies and the bads are pretty, significant though. It's hard to maintain if you do not build it properly. So you have to come in with a plan, you have to come in with a spec, and you need to know what you're doing. It is quite dependent upon people. So hypothetically, if someone leaves and they were the only person who knew about it, it's a single point of failure, which is bad. And the easiest way to fix that, document. But I mean, all of us know how bad that is. And if processes aren't laid out, there's always going to be knowledge gaps. There's going to be one person on the team who knows everything, and then no one knows anything about anything else. So, it is what it is, though. So, an example of the type of thing that we've actually gone and built is the security approval bot. Now, each of these different bots that I'm going to show you today are kind of explained through the process flow are actually AI oriented. And at the end, I'm going to also tell you about our AI bill, which is kind of fun. So the first AI bot is a security approval bot. Now, this obviously screams terrible idea to everyone here, because why on earth would you trust an LLM with it? And the truth is, you shouldn't. But the trick, there's a bit of a trick to it, and this is where you have to kind of change your way of thinking. Typically, security turns around and says no to literally everything. However, there are certain efficiencies that you can always gain by utilizing tools to your advantage. So you can have something like a Lambda polling for new tickets. It'll then go and identify possible, it'll start processing things, grab the different roles in this case. So we had fields in our forms stating, which role they actually want to take, and it will turn around and grab the authenticated user's email address. So it's something they can't spoof. The only thing they can really spoof is a predefined role. So it's from a Dropbox unless they can pop the actual form. There's nothing much they can really do there. So the bot will then go through previous tickets and documentation and then give some references to the engineer to make the decision. Now note that the bot is not providing any access, and that's basically how we kind of limit the amount of risk that we have. The bot doesn't know how to provide access. It doesn't have that access itself. All it has is read-only writes to tickets. Oh, actually write to, but So then after that, the human goes in, understands exactly what is needed, and then says, cool, based off X, Y, and Z, this team is allowed to have AWS access, or they're not. And then we basically change the entire flow. What this provides us is basically a standpoint and the equivalent of Jira's related tickets, just done in a way that it remembers what things are and doesn't keep fucking itself up. So, no. Then if you ever have to do vendor risk assessments that are terrible, terrible and disgusting thing, typically they take like 4 hours if you're doing a proper technical assessment and digging into every bit of documentation. So our team turned around and tried to build a bot. It was also one of the things that my team hated doing the most. Like think about a company, with probably 100 vendors or so. You have to do an assessment for every single one of them. It's hell. Now, what we ended up doing was basically we figured out that there was a consistent format that our GRC team loved to give us all the details. So we grabbed that, pulled that into a Lambda, basically ran all of that in, and allowed the bot to actually reach the internet, so do web searches and things like that. It would go through, analyze the vendor's documentation, and then with our master prompt, break down things into the exact way that we would normally do an analysis, and then put in a private comment into our ticket. What does that do? It basically gives the engineer a little bit of a leg up and decreases the amount of time. Instead of 4 hours, it takes about half an hour to an hour, because they don't have to go and look for the information all over the internet anymore. So saving time, but once again, just an efficiency, not necessarily taking over everything. Now the next one that we have, and this was one where it actually does take over everything a little bit more, but we have a Lambda that goes through, and so we created a learning system for an automatic ask security a question type thing. And all it does is it basically has a Lambda that goes through all the tickets that don't already have embeddings. This is where we have an RDS in the back, which is basically a Postgres server. All it'll do is go through all the tickets, grab the embeddings based off the API, and pump it into PG Vector, which is a Postgres database. Then after that, all it's going to do is go through, grab tickets that already don't have a response, and very, very simply just create embeddings from the original question that they have, pump that into the database, do a string match, or embedding match more rather, and then try to get an approximate confidence. What we did was we actually just built in variables for thresholds and then kept tuning the thresholds until we found it working right. And for us, it was typically 70% confidence and 30% kind of threshold on matching, which kind of, it'll depend on your actual company. And if you do want to know how we actually did the tokenizing, we used TikToken, and that was a 400 token window with a 50 kind of rolling overlap, which worked well for us. Once again, needs to be tuned and figured out. But yeah, the gist of it is that after that, we pump everything into an LLM, let that go through and make the decisions again, and then come back to the engineer and give a list of different references alongside their actual confidence scores and figure everything out from there. So it decreases your work once again, and yeah, it kind of works out pretty well. So this is actually our AI bill, which I think is pretty cool. 27 cents for the last month, and this month was 30 cents, which you can tell is a hell of a lot less than engineers. So trying to decrease the amount of time we spend on engineers and instead let those engineers go and innovate and do something useful with their time seemed to be a hell of a lot of a better idea for us. The gist of it here is that engineers are awesome. They build weird and wonderful things, and they can be cost effective if you allow them to be. So give them a chance, please. Thank you. Questions? Yep.
that a custom LLM or like from another company?
No, we actually just use GPT-5 right now. Nice and easy.
How is the AI so cheap? In my personal experience, for example, using like a subscription with Cursor, for example, $30 or whatever it is a month, and then they'll add. If you go over that, they'll like it's very expensive. It's best to go over. So how'd you get it so cheap internally?
So it's API based. Everything's done through APIs. You utilize it. So typically what we're trying to do is do pre-processing on everything. So squashing the data as much as possible using embeddings where possible, because embeddings are cheaper than actual text. And that squishes down the amount significantly. And we also do a lot of pre-processing on the data to get it into the database. And that is done through embeddings. So it's kind of like small little wins that you can take. And if you can do everything through the embeddings database, then you're actually spending more money on RDS than AI. And RDS money is just consistent anyway because it's a monthly bill. So we spend probably about $20 a month on RDS. So, yeah. So, thank you.
Awesome. Thanks, Sajeeb. Great talk.
Thank you.
Busy. And the prestigious Mesa Squad.
Thank you.
Thank you. Boom.